So let's press Control Space. I've got to create a location. I'm really bad at thinking of location. Let's just say I'm outside the castle. You stand outside a majestic castle. I can create a short description, which is the header for the location. So I can just call this outside the castle. This will appear at the top of the location. So you can see there the font is white, whereas the description is slightly off-white. This is more apparent the more text that you have outside of the header. So I need more than one location. So let's create another location inside castle. So what am I going to create? Let me create a spoon. So I'm creating a wooden spoon, and I have to create a location for it. So I type location. I have these locations to select from, so I can start the game with the spoon in my pocket if I wish. So if I type I, I'm carrying the wooden spoon. Let's say I want to put it inside the castle. Then I'm outside the castle, but I can't go anywhere, so now I need to connect it all up. So the navigation table lets me connect from the start location north to inside of the castle. So you stand outside a majestic castle. From here, you can go to the north. So I can click north or south, or I can type north. I think I can type south fully. I can type north fully. I can type S and N. It's the same thing. But here I notice the wooden spoon, so now I can get the spoon. And sometimes you just want to see nothing special about the spoon. Sometimes you want to add a description. Now the examiner message, I'm not sure that I've wired this up. I'm not sure that I have. So oh, I have. I've wired up. So that's the simple way to get an examiner message on an object. But there are other ways to be able to interact with objects. Pretty much you can do anything by creating text processing patterns. So these patterns go into the code section and the input handler. So this is the handlers that handle logical sentences that you type on the command line. So let's if I type in, let's say, throw shoe. Well, it's dealing with this as pure text, so it doesn't even matter if there's an object there. I haven't qualified this, so anytime I type in throw shoe, this block will execute, so I can type in something. So if I type in throw shoe now, I will get that response. But usually what happens is you would want to have an additional criteria for matching this pattern. So let's say I want to do something with the spoon, then I would need to qualify this statement within here to, let's create another object, which is a broken spoon. So now if I type in break spoon, These hovers are getting on my nerves, so I'm going to I'm either going to shrink the hovers or put in a different timeout, or be able to toggle the hovers on and off, because they're obviously slightly getting in the way. One reason is that I've zoomed in for the purpose of the screencast. Usually these would be a lot smaller. But I will add a hover toggle so that they don't annoy. I hope you didn't require a spoon later on in the adventure. So typing in break spoon will happen anyway, even if you're not near the spoon. And that's just printing a message, it's not actually doing something. And I can just keep typing that in again and again and again, and it's not qualifying it. So what I actually want to do is qualify it. So if I create an if statement here, if object is present, spoon, then I want to print this message. Oops. I'm going to indent that by selecting the line and then tab. And what do I want to do? So then what I want to do is destroy the spoon and create object spoon. So that will create the object. And then I maybe want to redescribe the current location. And maybe I want to put a pause here so that we can read that text. Because when we redescribe, we clear the text. So I'm going to wait for a user input here. So redescribe will always clear it. We don't need to do a redescribe. So that's the logic. We can break the spoon, but only if the spoon is present. So if we break the spoon, nonsense. These responses will get better. So we have a spoon here. Now we should be able to break the spoon if the spoon is there. Oh, so I've destroyed the spoon and I've created the spoon. Actually, what I want to do is create the broken spoon. Now I have a broken spoon, which might be an object that I need for another puzzle. But obviously, break is not something that might come to mind. So what we might want to do is create some synonyms for break. So trying to remember where everything is. It's been a while. I haven't worked on this in a few weeks. It's probably in the tables. Yeah, vocabulary, words, and verb is a doing word. So if we create a break and assign snap to it, now snap and break become synonyms. So let's try that. Snap, spoon. Spoon snaps clean in two. If we restart again, break spoon does the same thing, but we only had to match on break. So this will become associated with this word definition. If there are no aliases, then we don't need that. So this is like the lazy way to do it if you only want one word to be accepted. But if you want to define aliases or synonyms, we can use this structure, and that happens on a word category basis. So it's aware of if something is a verb or a noun or an adjective, so we can have different aliases based on that. So it keeps track of these vocabulary words. And I don't think you have, I think it also, you don't need to use the key. So if I use snap here, so if I say snap spoon, that works. If I use break spoon, so it's keyed So you can use this as a key or this as a key. You can use any of the aliases as a key. But we also need a primary inside here. So yeah, that's how word aliases work. That's how we match patterns of text. Now let's say we want a generic response for something that we're snapping that isn't matched with anything else. So let's say we want to snap something, and we just want to inform the user that that's not something that they can do. Okay, so let's say snap. So now we've put a catch-all in. So that's a message if I try to snap something that's not permitted for me to snap. But if I can still snap the spoon, and it would match the first pattern first. And what this redescribe does, redescribe will break out of matching all of these patterns. So we'll try to match each pattern in turn. So we'll try to match this pattern, and then it will try to match this pattern, and so on. There could be hundreds of these things. But if a redescribe is encountered, then it breaks out of the pattern matching loop. Or if a done is encountered, it will break out of this loop. The done is kind of redundant here because a redescribe it redescribes and then it also breaks out of the loop. So a redescribe done is benign, but the done is redundant. So we can also do things like it's quite good sometimes, just instead of purely waiting for user input, to have a beep. Now I don't think the beep is going to work because I don't have the sound wired up, but you know, 500 and pitch is 0. I'm not sure if this hover works. No, it's not quite working with pitch. Let's have a look. Now I need to work on the hovers in this particular syntax, but pitch, I think it'll tell you if you go to, like, if you put in a stupid number, like 100. Yeah, so the pitch must be between minus 60 and 16. I think 0 is middle C. So if you just want to go up an octave, it's pretty easy. But sometimes it's nice to have a beep event. Now, let's say we want to do something only one time. We can use like a Boolean flag. Has printed joke. And the default value there sets to false. So if we say pattern joke, and we can have an if, and this means not. If we haven't printed joke, then print a joke. Now I have to think of a joke. I have no joke to print. Oops, I just want an else here. Oops. So the way that this is working is that set Boolean I'm going to move this over here so you can see more of it. So if I type in joke into the adventure, which of course wouldn't be a normal thing that I type into an adventure because the player would not be aware to type in joke, but just for the purpose of showing how the pattern matching works and how the variables work, if I type in joke, the first time I type in it will print out, why did the chicken cross the road? Which isn't a good joke because there is no punchline. But now the next time that I type it in, this will not evaluate to true because printed joke will become true here. So the next time it encounters this, it will be this will be true. So therefore, the overall statement will evaluate to false. Therefore, it will print this every single time I type joke afterwards. So if I type in joke, I have no more jokes. If I type in joke, so what I've done is I created kind of a latch where it can only go into this logic once. So this is kind of latch mechanism. So if you want to be sure that you're not running the same logic twice, then you can do that. And so far we've only really gone into the T1 pattern matches. There are other types of event handlers. So T2 will allow me to execute subroutines on when something is described. So I can replace that with these bracy brackets. So if I think first I'm not sure about this. Ignore that. I'm going to go into that in a different video. This is just really showing the way that objects work and the way that pattern matches work. There are lots of operations that can be invoked here. Okay, that's it for now.